Our next speaker is Evgeny Peshkov from Dodo. Hello, Evgeny, can you hear us? Evgeny, could you tell us the following thing? You will be talking about the bounded context. This is something from DDD, yes, this is about domain-driven design. It's one of the strategic patterns that is used in DDD. I will tell you why it is used and how it is used. In Dodo Pizza, you are using DDD extensively or not. We use it, but we still are on our way to extend it. DDD, on the other hand, is not just some specific practices. It is just about just interaction with business, meaning that we still are using DDD extensively. At Dodo, you just have one product created by one team, or you have several teams working on dedicated products. We have apps for the mobile devices, for website. We also have the DDD IS central hub that includes pizza management functionality, and as well as providing API for other backends. We also have completely different apps right now, the Mir app and the Cafeania app, the coffee shop app, so we are working to develop them. The DDD practices, do they help you to successfully implement your IT systems? Yes, they do. Just yesterday we had the Haber article published on Haber. They expressed their experience and they described their experience there, and of course it's quite positive. On this positive note, I'd like to turn to your presentation. Please, you have the floor. Hello everyone, my name is Evgeny Peshkov. I am a developer at Dodo Engineering. Our company at the moment is called Dodo Brands. It's one of the key brands of Dodo Brands is Dodo Pizza. Probably you will learn more about Doner 42 and Drink It brands. We are present in 13 countries with over 600 catering points. Dodo Pizza is managed by our management hub. Our Dodo IS platform is used to manage all those pizza shops, and we are developing this platform. A few facts on Dodo IS. The system includes almost 50 services. We get about 150 orders per minute, and the team includes several dozens people. We produce almost everything using C#, using ASP.NET. We use the MySQL database. All this is located in the cloud. We use the Microsoft Azure. We also use containers and Kubernetes. We started from a typical multi-tier infrastructure with a database and with a server. We had the IS server, which was used to launch our first simple website. Then we added more websites. We added some specific features. We added some specific features to projects and to sites. All this has been developing and it has been growing, and it then transformed to a major project that we call the Dodo United project. It includes about 200 projects, and all this is deployed and then it is developed also. It works as traditionally we have the application layer and also the repositories layer, and we also have the database on request. When we started, databases were not that popular, and we use Diaper mostly. We create queries by hand using these repositories. This is the list of our services. In the middle column, we have the monolith. which includes our backbone. Monolith is not just about something we deploy, it also includes other things, and the key issue there is that everything is interconnected. There are a lot of services that are inside, they can impact each other, and this is a key issue, and sometimes this influence is negative. What is the challenge in our industry? It is that the complexity of the system is always growing. With time, our application is snowballing. It is becoming a big behemoth structure with interconnected elements, and of course it's very hard to take just one service and distinguish it to then scale it, or to cut it, or to modify it, or to prevent the use of some sensitive data. The key thing is that this complex system is growing. If we don't address complexity, it will be even worse. DDD is actually used to reduce complexity. This is its key feature. It is to reduce the complexity of those systems that you are developing. We can tell you that complex systems can be divided into technical complexity and business complexities. Business complexities are not addressed by DDD yet. In terms of business complexities, DDD is a nice thing, and of course DDD is one of the tools to address business complexities. Looking at books, at references, we remember the 1999 article of Big Ball of Math, and we know from that we have a lot of sources of complexity and entanglement. The authors are talking about very relevant facts that are still relevant, that are still actual. They are talking there about the fact that very often we create codes for no reason. We create some prototype, we won't be producing it, we just will check some metrics and then we will modify it. Yet after that, there is a different stage. The next stage, the code goes successfully to production, and it is successful. And of course, there is no time to modify this old code, and we start just developing it to using some tricks and tips to make it work. I'd like to make a few other points. I'd like to tell you that designers very often hope to use some new technologies, and they bank on those technologies. Message brokers or some other brokers are considered to be something that can address a lot of issues of designers, that they can address a lot of challenges, and of course designers very often study marketing materials and they start buying those tools, and of course they after that face even more problems. In the industry, we've seen a big focus on databases. It is now being blurred, but during our university college time, we were told that you first need to design a database to be able to store our states, and then after that, to that database, we will need to add anything else. This is what we remember from schools. Designers, developers do not focus on object naming and methods. Of course, it's good to have a good naming, and it's good to be able to name your objects and methods in a way that is understandable by business. Otherwise, you might face a number of challenges. You might face a drift between reality and software. In software, you have one naming, while in reality, managers call it differently. This leads to a number of challenges and issues. Now we have a lot of unconnected, disconnected tasks. We are always aspiring to develop some features, and our features might become unstructured. We might add some subparts, some new features, or modifying some older features. As a result, our product is being developed, and it becomes very complicated, involving numerous elements, involving some other components. As a result, the team doesn't have time to focus on a particular product or a particular product section. They just make their own features and leave, and continuously the quality of such a product is going down. We have the Boy Scout rule telling us that you need to leave a better place after your work, after your intervention. But at the moment, I see that many teams lack it. Many teams lack it because they feel the pressure of deadlines. And we have otherwise, and this entire rule we call the hotel rule, when you just use something as a towel in the hotel and then you discard it, and that's it. In such a case, you need someone to tidy up after you, to clean up. Yet our track record shows that your product with such an approach will be degrading, and the complexity I've been talking about will be growing faster and higher. Now, complexity is emerging and growing. We are seeing increasing complexity, and very often, instead of well-structured apps, which initially had a very refined infrastructure, they become blurred, and they are diffused with layers and tricks and tips. All this leads to higher complexity. One more point is that we have another major challenge in terms of coding. It leads to higher complexity and higher interconnectedness. I am speaking about flexible universal models. In the industry, we have had a number of traditions. For example, we have an order. We start creating a cash desk for a restaurant. We create an ID. We create amounts, taxes, and composition. Then there is another part of the system. We want to add another domain and automate it. Very often designers see that they already have the order, which is resembling very much what they had before, so they just add some fields, they add phone number, delivery address, and time of delivery. Then we have the accounting layer, they add the accounting layer on top, they add ingredients, and then more features come, and the object, the product is growing even more and reaches a very big scale. And we see now this universal model emerging. It looks like an usher staircase with all the elements that are approved, that are connected, but when you look at it, at this model in its entirety, you cannot understand how to use it. I really hope that universal models are a bad thing, and the key thing is to simplify your models and that you don't use those flexible universal models. Why universal models are bad? First of all, this is because every time they use only just a section of the model. Speaking about delivery orders, it is no matter how many boxes have been discarded because of the orders, and if we look at the order in terms of the content, it's no matter for us what should be the time until we need to deliver the order. The next issue is related to the previous one. You cannot understand from what side you need to expect the null reference exception channel. We don't know exactly how often and how full our universal model is filled, whether those ingredients are filled if we get this from a courier service. We really every time have to compile this in our head and try to unfold this cycle to understand how it's filled. There is one more issue. You need to understand how that there are a lot of excessive data in every object. If there is a pizza order, we have everything that is connected to the order with pictures, with ingredients, with a lot of other data. And of course, this is excessive information. Very often we don't need it, and this leads to higher memory allocations. We faced similar issues. We found some bugs in our codes. We got very big objects, so we started working with the picture massives, and we saw the result in the telemetry. These are the technical bugs, the technical issues. Yet, on the other hand, universal models do not have a border, do not have a frontier. We have to look at an object having like 40 fields, and we want to understand its invariance, whether it should be concerted or it should not. New developers who join the team and who join with the approach of this behemoth approach, they are thinking of whether they should use another field. If you have already 30 fields, should you add another 31st field? Because it wouldn't be worth in any way. So this universal model is becoming this snowball, this ball that is misstructured, that is interconnected and prevents you from seeing its scale, scope, and other parameters. All this leads to the fact that the complexity of the system is growing increasingly. You probably heard about the don't repeat yourself principle. You probably think that the universal model is about dry, yet dry, in my opinion, is about logic's repetitions more. In the DDD community, we support the rich domain approach when an object is able to understand their own invariants and change their states themselves without using any services from the outside to do that. So the logics on how to change the state of the object of an instance of the courier, for example, this logic should be implemented in just one place. The DRY approach, the dry approach, is an important one, but it's not really relevant. It's not related to fields. Probably your system would have a lot of instances, and in such a case, it might work quite efficiently. If you have a sustainable approach, in DDD we use some dedicated approaches. The key slogan is each model should have its limited context, bounded context. No, bounded context. What is a bounded context, which is the key topic of our presentation? A bounded context is something that is used to understand the applicability scope of the model inside your big system. You have your big order with a lot of ingredients, with a lot of elements, with a lot of couriers and shifts. We see these two instances, and we split the order into several instances, and we know in that case what to expect from a particular order. We also know that all fields should be filled, and in such a system invariance will also be supported in such a system. Now, the scope of applicability of each model is something that we call the bounded context. The bounded context, which includes a model which has its own sense, so to say. How do we find those limits? This is a non-trivial process, a non-traditional one, and probably there is no just a simple one-fits-for-all approach to understand limits. Let's look at what kind of focuses we have here. First of all, we need to look at data. What is the source of data? Where do we use data? Whether we use together or separately. We need to analyze your data lifecycle, and in that case, you might have better results. Domain experts. In DDD is about communicating with domain experts. Communicating with them, talking with them, you might understand that those industry experts will tell you more about positions of different roles, functions to one or another aspect. So if you do that, so probably you will need to be able to understand, and you will understand the best way to development. Organizational structure is another thing. You will need to pay attention to the following fact: if you automate your enterprise, if you have a sales department and you have a marketing department in your team, then of course for them you should have various different bounded context. Now, we understand that logics and structure might not always be logic. Org structures, organizational structures, are often created by through some political decisions, through some covert activities. It's just for you to understand that you need to consider it. There are a number of business processes that I want you to focus on. You need to focus on the stages of business process. Business process stages. If you have a business process, and if you have some other processes which is changing all the time, if you have some important events that happen, it probably is another hint that you need a limit. Stakeholders. Stakeholders are important. You need to understand the role of a particular person, and with this work, you will be able to understand their approaches, and people for that probably might need different instances. Single language. I've mentioned that the importance of naming is critical. A single language is one of the patterns, one of the strategic patterns for DDD. It is about that you have to understand each term in your context with a single sense. Speaking about orders inside your model, this order should be treated, should be understood as a single pattern, as a single definition by all stakeholders. If you develop a bounded context for accounting, and if there is an order word used there, of course everyone understands all the attributes to this order and the attributes that shouldn't be there connected to the order.
Что еще важно? Важны агрегаты, да, то есть, собственно, те
aggregates.
Еще поговорим.
We will talk more about aggregates. Aggregates are also important. An aggregate is a collection of entities that look as something intact for consumer, for end customer. One of the most dynamic tools in the field of DDD, in the DDD world, used in particular for understanding bounds. This is the event storming approach. Event storming is a facilitation technique which helps assemble, which helps collect domain industries and developer teams. Before COVID, it happened in offline format, and we recommended the in-person approach here. Stickers and markers and physical contact, of course, they are good for communication. But after the corona crisis came, people started doing that online. It is possible, it is a bit more complicated, it is harder, but it is now taking off. We use Mural, we use Admira, but you can also use Mural or other online editors for you to be able to use this virtual flip chart to place your stickers. We start from a chaotic survey, chaotic research. Event is in the center of event storming, and the domain event is the key thing here. You just place your sticker on the flip chart. Each participant provides his or her own ideas, so we collect domain events, for example, things from the past, or verbals, for example, order placed, order transferred to courier, order cancelled. So we place those phrases on the flip chart. And of course, duplicating is quite okay. We have these verbals like we received the new order, or the order is placed. So we need not always think up a perfect name for such a sticker. Probably a perfect name will come a bit further. Such differences in naming can tell us that people treat instances, treat domains in a different way. This will be probably one of the limits, one of the bounds in the context. The last event might be the last event in the previous chain and the first chain for the next chain of various bounded contexts. After that, we have the global streamlining stage. Our pattern, our patchwork is a dedicated timeline. Our event is placed on this timeline, and we get to understand some parallel events, some independent events. Some activities can happen earlier or later, and we can have a clear picture on that. We will also need to look at pivotal events. A pivotal event is an event which greatly changes a system. In such an example, in our example, this event can be the placement of order, the order placement. Before that, we didn't have an order, and we didn't have any different process. Users probably log in, they might put something in the bag, and then after the placement of an order, then there is another flow happening, starting to happen. This happens again at the limits of different contexts. If we map our patchwork with these events, with these patchworks, we will be able to understand our limits. The next important stage, the next milestone is understanding stakeholders and systems. So we put those stakeholders and systems in some particular spots on our patchwork, on our activity patchwork. So we add them there, and different stakeholders will be able to show us that probably there is a particular activity, a particular event treated by various sites, various stakeholders. We probably will need a bounded context for couriers and customers, and those two contexts will probably not intervene. These will be two different contexts. Probably, most probably. The next thing is validation. We have the timeline, we have the event, and we can tell a story. We can tell a story to our user. This is the storyline of our customer path. A customer logs in, places an order, he then gets the order delivered. Here we understand what kind of holes we might have in this system, what kind of loopholes there are, and we will be able to add this to the storyline. In such a case, very often we start to understand that there are a lot of things that we need to understand. We probably will need to just highlight it, and the key thing is for the workshop is to make a model perfect, and we want to add this model. We want to make it as efficient as possible. This is just to say that we need to think about the knowledge transfer from experts to designers. The next thing is highlighting context and separating contexts. We use some key events. We also use some tracks of events of the business processes I've been talking about. We also look at some actions, some activities, and we also look at stakeholders. So these are the things that help us delimit our context. There is another tool that is helpful in terms of context management and in terms of documenting. Bounded context canvas is the tool that includes a number of squares, a number of areas where we integrate some data, some information we received at previous stages. We provide names to those squares, and we also name our contexts. We describe those contexts, and we include inbound events, inbound queries or commands, and we also identify events and commands and operators generated by those inbound events. With this, we can understand the amount of communications, to a particular context, whether it is important, whether it is critical or non-critical, and we are able to understand its current position and why it's positioned like that. We will also be able to probably transfer some responsibility to a different context. So probably we spend a lot of efforts and we probably have a lot of responsibility to a particular bounded context, and we need to split it into several contexts. Now, all this is quite helpful, and it helps us to get a clear picture and some general view on our bounded context limits. It helps us, as I already mentioned, to understand some map. There are no exact answers, so we build this general picture, as we call it, naive picture, and we split our system into several bounded contexts. And of course, probably from scratch, we won't be able to find the right answer, and we will probably need some further steps. Yet, initially, we might not be correct, we might not be right in our approach. Moreover, our system is a live system. It is always constantly, continuously changing, and of course, it's quite critical to look at its consistency, at its integrity, and of course, it's good to look at the consistency of different divisions from this or that matter. We might have a split in bounded context. This is our first split. We get a number of limits, a number of areas and domains, and after that, after some time, we will be able to understand that a part of our responsibility is split, involving some inconsistencies. In such a case, we might take a decision to move part of the code by changing responsibilities from one context and moving it to a different context. We, at a particular point, understand that the context is probably too extensive, it is excessive, and of course we see that the model there is inclining to universality. It is possible also to understand that we need to make changes because there was some reorganization. For example, our sales department was split into sales and marketing, or something else might happen, and it might enable us to adapt our framework, adapt our system, because we want our system to be able to suit our business structure. We want to make limits smoother. We want to split responsibilities, probably add some responsibilities to a particular team. We want to have better limits, which will be strict and clear. Some limits, some bounds might be lost. We understand that just two contexts, and in microservices world, context might be too talkative, as they call it, when two contexts communicate a lot with each other, so probably it's a good way just to combine those two contexts. We just want to rethink our approach in this case and combine our contexts in such a way. This will then help us avoid further issues, because it will be a perfect solution. I've mentioned microservices. Microservices and bounded contexts are interrelated, and I'd like to focus on their links and how they are connected. Before that, there was a widespread opinion that microservices and bounded contexts are two things coming together. They are having this one-on-one correlation. It's possible to split just one context and put it into a microservice. It's not untrue completely. You can do that, and if you can do that, of course, it's quite welcoming. This means you will be able to perform well. If you want to have a microservice architecture, it is a nice approach, and you need to aspire to it. Yet it's not always possible, it's also always feasible. We see that at the moment there are a number of approaches that help us understand that a microservice, a bounded context, can be represented in several services. There are probably some legacy aspects that make your bounded context being able to split in many microservices, yet it is an exception and it's not a sustainable, it's not a good solution. The next issue, whether should we transfer bounded context to microservices? I don't have a ready-made answer to that. Everything depends on the situation. If you have a well-structured monolith, we are having this popular approach, which is called the monolith-first approach. If you use that, if you use the module monolith that uses each bounded context separately, if you don't create universal models there, then of course probably you shouldn't split your system into microservices just for the sake of microservices, just for the sake of having a clearer bounds, clear limits among bounded contexts. You can implement a sustainable approach using a monolithic approach and systems. The monolith-first approach recommends just this. In bounded contexts, internally they might communicate in using the eventual consistency mode. You won't have the strong consistency. You remember that from the monoliths. In current context, we really feel that we need to focus on a number of approaches. You can use the async or lineups. Of course, it's more complicated. And it's harder to explain it to customers. Yet it makes things easier. It makes code more consistent, and it helps dividing into teams and reduce cognitive load. What we get if we use bounded contexts? The cognitive load is going down. This means we don't have to think on the breadth of responsibility, whether the model is fulfilled. We just have our own small piece, a small section. We can do it well, and we can get this piece to a dedicated team, and this team will polish it by adding some obvious modifications. With this, the code will be more structured and it will be cleaner and more refined. We have the obvious contract and invariance. If we have a courier, then of course we need shifts for those couriers. If there are no shifts, we cannot provide and transfer the order to couriers. And we can insert this, we can integrate this in obvious contexts and contracts. Developers can invest in model refinement. They improve it and make it better. Using bounded context helps us also communicate with industry experts because we need to do that to have a better code. Of course, bounded context is something that supports this endeavor, this initiative. We also get, as a result, high cohesion and low coupling, as we call it. Each bounded context we have is bounded. It has an integrated design, yet we have very low connectivity between two different contexts. They can be async and they might not influence each other. Using bounded contexts will simplify your work, will simplify your coding. In the conclusion, I'd like to show you this picture of garden. A bounded context is something that you have in your kitchen garden. You have your patch of land, and you as a gardener, you need to take care of those patches, and you need to respect the limits. If you do that, if you do that, it will be quite beautiful. If you don't do that, the limits are blurred, and your garden will be a nightmare, will be a forest. If you do that, if you take care well, you will be successful. Thanks.